Chapter 6, Section 6 is about properties of kites and trapezoids, two new shapes. So by the end of this lesson, you should be able to use properties of kites to solve problems, and also use properties of trapezoids to solve problems. So let's talk about kites first. A kite is a quadrilateral with exactly two pairs of congruent consecutive sides. So remember, a quadrilateral has four sides. But the difference between a kite and a rhombus is a rhombus, remember, is a parallelogram. For a kite, it's just quadrilateral. It has four sides. It says nothing about sides being parallel anywhere. So here's a kite. You have two pairs of congruent consecutive sides. And then here are some properties. If a quadrilateral is a kite, then its diagonals are perpendicular. And then if a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. So the thing is here is it has to be in between the two consecutive congruent sides. Now, one thing that you need to watch out for is this angle here and this angle here are not congruent. So it's just the ones that make up the pairs of sides that are not congruent. And that has to do with the fact that if we cut this in half with a diagonal, we have two triangles there, and we can use side angle side to prove that those two triangles are congruent. So let's do some problems. So in this kite ABCD, the measure of C to D to F, so this one right here, is 52 degrees. And they want us to find BCD, so they want us to figure out this angle up here. So now remember what the properties of a kite tell us. It says that we have two pairs of consecutive congruent sides. So these two are consecutive congruent sides, and so are these ones. And then basically all we need is the top part of this triangle, or of this kite, because it forms a triangle. And this triangle is special that we have here, B, C, D, because I know that these sides are congruent. So that makes it an isosceles triangle, and if this is 52 degrees, so does this. And then we can use the fact that all angles in a triangle add to 180 to figure out this last one up here that we don't know. So we're going to take 180 and subtract 52 twice. So we're really subtracting 104. And that gives us 76 degrees. So I know that the measure of BCD has to be 76 degrees. Alright, so in this example we have the same kite, and they remind us that CDF is 52. Remember, we just found that this one up here is this 76 degrees. And then they tell us one more piece of information, that DAB is 54 degrees. And our job is to find angle ABC. So this one up here is what we don't know. So when we take a look at this, we're given a ton of information. This 52 we're not actually going to need for the problem, so let's get rid of it. Remember that we have opposite angles that are congruent, and they go in between the pairs of opposite sides that are congruent. So I know that this angle up here, ABC, has to be exactly the same as this angle down here, ADC. And then I can use the fact that every quadrilateral, the interior angles add up to 360 degrees. That goes back to this formula here, times 180. So when I do that, I can say that I have A, B, and C, and D have to add up to 360 degrees. So angle A plus angle B plus angle C plus angle D have to add up to 360. Now I know some of these angles. I know angle A is 54 degrees. I don't know angle B, so let's make it an X. I know angle C is 76 degrees because we just solved for that. And I don't know angle D, but remember these two have to be congruent. So this is another X. And then this just turns into a nice easy algebra problem. 54 plus 76 gives us 130 plus 2x equals 360. And if I subtract 130, you end up with 230. And if you divide by 2, you end up with 1, goes into it once with 1 left over, 115. So that means that each of those angles up there have to be 115 degrees, and that the measure of ABC is 115. Let's try one more example. So this is a different kite. It tells us that the measure of P to Q to R, so this one up here is 78 degrees. And it tells us that T to R to S, so this one here is 59. Our job is to find Q to R to T. This one here is what we don't know. So some of this information is totally useless. They're just giving it to us to confuse us. Whenever I look at a kite, I see two isosceles triangles in here. This one on top and then the one on bottom. Now the one on top is actually all I need to find the angle that we're questioning right now, because they tell us up here 78 degrees. They tell us that those sides are congruent, so that tells me that these angles have to be congruent. And with the fact that all of those angles have to add up to 180 degrees, that gives me enough information to find the angle measure. So if I take away 78 degrees, I have 102 degrees left that I have to split evenly between those two angles, because they have to be congruent. So if I cut this in half, I end up with each of them have to be exactly 51 degrees. Alright, so let's switch gears and do some trapezoid stuff. A trapezoid is a quadrilateral with exactly one pair of parallel sides. Each of the parallel sides is called a base. The non-parallel sides are called legs. Base angles of a trapezoid are two consecutive angles whose common side is a base. So B and C are base angles, and A and D are base angles. So if the legs of a trapezoid are congruent, then the trapezoid is an isosceles trapezoid. And these are pretty awesome because they come with these three theorems. But if you want to think about these, this was just a isosceles triangle that somebody like sliced. So we still have some congruent stuff, which tells us a lot about the rest of the parts of the triangle. So if a quadrilateral is an isosceles trapezoid, then each pair of base angles are congruent. So remember, that means these top two and these bottom two are congruent. If a trapezoid has one pair of congruent base angles, then it is an isosceles trapezoid. So this was one of the triangle theorems that we kind of did backwards and said, if these base angles are the same, then I know that these sides have to be the same. And then a trapezoid is isosceles if and only if its diagonals are congruent. And remember what this means, if and only if. It means it works forwards and backwards. So that's why we have this double-sided arrow over here. So if they are congruent, then it's isosceles. And if it's isosceles, then your diagonals are congruent. So let's use that for some problems. Find the measure of angle A. So we're looking for this guy down here, and we don't know. So when I take a look at this, I notice that I have the parallel lines here. AB and CD are parallel. It always helps me if I draw my parallel lines out nice and big. Now the only piece of information they give us is angle C. So I'm going to see how I can relate that to other angles. Pretend this right here is a transversal. Angle C and angle B are same side interior angles. And we know same side interior angles are supplementary. So if this one over here is 100, that makes this one 80. And then I can use the information that because this is isosceles, I know this angle, angle B, has to be exactly the same as angle A. So both of these have to be 80 degrees. So angle A is 80 degrees. Let's try another. JN is 10.6. So from here to here is 10.6. And NL is 14.8. They want us to find KM. So they want us to find this thing right here, all the way down. So if we go back to our conditions here, we have a trapezoid because we have two parallel lines, KL and JM are parallel. It's an isosceles trapezoid because we have those two slashes there. And remember, this last one says, if you have an isosceles trapezoid, then its diagonals are congruent. So we know that KM has to be the same distance as JL. Now we don't totally know JL, but we know JL is JN plus NL. So we know this equals 10.6 plus 14.8. And if you add those together, you get 25.4. So KM has to be 25.4 long. Let's do one more. Find the value of x so that PQST is isosceles. So we want these two to be congruent. So remember, in order for that to happen, these two angles have to be congruent. So we want 2x plus 2, or 2x squared plus 19 to equal 4x squared minus 13. So then this turns into an algebra problem. I'm going to move my x squareds over here. So I get this, minus 13. And then add 13 to both sides. So we get 32 equals 2x squared. Get the x squared alone. So 16 equals x squared. And then remember, to undo a squared, all I have to do is take the square root. So x can be positive 8 or it can be negative 8. And then we could plug it in, but make sure you read what it's asking. It says find the value of x so that they are isosceles. So once we found x, we're done. If it asked you to find the measure of angle Q or the measure of angle S, we would have to plug it back in. So then there's one more thing about trapezoids. Remember when we did triangles, we had mid-segments. So it was something that cut right through the middle of two of our sides. The mid-segment of a trapezoid does exactly the same thing. It's a segment whose endpoints are the midpoints of the legs. So this right here is right in the middle of this leg, and this is right in the middle of the other one. So right in the middle tells us that we have some congruent parts. So then we have a theorem. The midsegment of a trapezoid is parallel to each base. So BC, XY, and AD are all parallel. And its length is 1/2 the sum of the lengths of the bases. So this right here is just telling us basically it's the average of the lengths of the bases. So let's say that I had a trapezoid here, and I told you that this was 10 and this was 6. The length of this mid-segment has to be halfway in between those two numbers. So you add them up, divide by 2, this would be 8. So let's do a problem. Find EH. So this problem's kind of backwards because it gives us the very longest one. It gives us the one in the middle, but it doesn't give us the shortest one. So remember, the longest one and the shortest one have to average together to give us 16.5. So I don't know what this is, so let's make it x. But I know that FG plus EH cut in half has to equal XY. So plug in what we do know. FG is 25. EH, I'm going to make x. Cut in half equals the 16.5. And then, like always, this just turns into an algebra problem. So if I multiply both sides by 2, the fraction goes away, and we end up with 33. And then if I subtract 25 to get x by itself, we end up with x has to be 8. So that means EH over here has to be 8 long. And you can double check this. 25 plus 8 cut in half should give you 16.5, and it definitely does. So that's it. You should be able to use the properties of kites and trapezoids to solve any problem that I throw at you. We'll do some practice in class. Make sure you write down any questions you have, and we can go over them. Have a good night.